All right, here come the acids and their derivatives. These are the 5 functional groups we'll be studying in this chapter. So acids, esters, acid halides, amides, and nitriles. These are all carboxylic acids, and then the other 4 are derivatives. The naming priority goes as follows. Acids have the highest naming priority of any organic functional group. Second highest for us will be esters, then acid halides, then amides, then nitriles. After nitriles comes the other ones. So after nitriles, then we have aldehydes, ketones, and alcohols, amines, etc. So all of the ones that we have studied previously. So we're just adding everything on top. And as we know with naming priority, we want to give your highest priority functional group the parent name, the suffix. And so we'll look at these 5 functional groups, and we'll look at the prefix and suffix names, and then we'll do some examples. So, carboxylic acid. What we do for carboxylic acids, the prefix is carboxy, although we do not normally see this because this will only come into play if we have multiple carboxylic acids and one of them is not on your longest chain or on a ring or something. And the suffix term is oic acid. So for example, this molecule here, the acetic acid, technically is based on ethane, right? There are 2 carbons in this chain. We're going to drop the E as before. We're going to make this ethanoic acid. So we simply will have our suffix ending oic acid there, get rid of the E as always, like ethanone. I guess that can't exist, but ethanal for an aldehyde. Remember, we just add these suffixes after the N. So ethanoic acid there. Again, carboxy is not something we generally see, so let's just avoid that. For esters, something like this, an ester, let's use another color. The prefix for esters are alkoxycarbonyl, and you'd replace alkoxy with whatever it happens to be. In this case, it would be methoxycarbonyl. For example, if we had a carboxylic acid here, the carboxylic acid takes priority, we would say 3-methoxycarbonyl, because that alkoxy bit is what's on the other side of the ester. So this part would be the alkoxy. So we would say methoxy, whatever it happens to be, isopropoxy, ethoxy, whatever it is. Carbonyl, that's what it would be. So this compound here would be 3-methoxy. Carbonyl, propanoic acid. And we also will put the ester within the parentheses, like we would for any other kind of substituent within a substituent kind of thing. So because esters have the 2 parts, right? They have the carbonyl part and then they have the other side of the ester. If you have a suffix ending, what you have to do is label everything that's on the oxygen side of the ester first, and then you're going to, here, we'll do an example. Why not this? You'll name everything that's on the oxygen side of the ester first as a substituent. So we're going to have 2 names. This one will be phenyl acetate or ethanoate. And we'll take a look at this name here. Here on the left, we have everything on the oxygen side. Everything on the oxygen side of our ester. And if we had a methyl group there, we would have to say, 4-methyl phenyl ethanoate with a space in between. So whatever you have on the oxygen side, you have to label first, and then you'll have a space, and then everything on the carbonyl side. So this is everything on the carbonyl side. And we name this at the end O8. So as if it were a carboxylic acid, like that would be ethanoic acid, we call this ethanoate instead. So this would be phenyl ethanoate, would be the name of this ester. Another one would be this one, on the other hand, would be ethyl, because that's on the oxygen side. And then we have benzoate. So again, similar to what it would be for the acid, like benzoic acid, if that were a hydrogen instead of an ethyl group, that would be benzoic acid. But if we have an ester, we need to have the O8 ending. Interestingly enough, carboxylates also follow this naming structure. This would be sodium benzoate. So we can kind of consider this an ester, even though it's not. It's a carboxylate. But there we have it. So sodium benzoate, of course, a very common preservative. It's in many of our foods. You'll see that often enough. We would have the negative here. So that's an ionic compound made after benzoic acid has reacted with a base, like sodium hydroxide. So that's our ester naming. So first name the oxygen side, space, carbonyl side, end with O8. All right. So that was the esters. Let's look now at acid halides. If we have them as a prefix, we call it halocarbonyl. And that halo will be chloro, bromo, whatever the halogen happens to be. Here's one we can do. Why don't we do this one? It's got an ester and an acid halide. So for this one, we have to look what's our highest priority group. It's the ester. We have to follow ester naming rules. So in order to name the ester, there's two parts. We have the oxygen part and the carbonyl part. So we're going to basically break our molecule along that ester bond and name everything separately. So on the left, on the oxygen side, we have a methyl group, and that's it. On the other side, we have, so carbon 1 is going to be your ester carbon, your highest priority carbon. So on carbon 2, we have 2-chlorocarbonyl, and then we will have the parent name, which will be the ethanoate again, because we have 2 carbons there. Ethanoate. So methyl space, I'll make that space really obvious, space parentheses 2-chlorocarbonyl ethanoate. Pain in the butt. But, okay, yeah. Of course, if you have your acid chloride at the end, you will end it as following, if it's a suffix. If it's your highest priority group, you end it with oil halide. We can kind of actually, it's sometimes just YL, sometimes it's with the O, it just depends. So eel halide will work here. So for example, if we have this compound, this would be benzoyl chloride. I'm going to put the O there, why not? It is more common to have it with the O. So benzoyl chloride tells us that we have the acid chloride as part of benzoic acid. We name these as derivatives. So we look at what it would be. It's benzoic acid is what like the original compound is, and then it's derived to be the chloride of that. So it's benzoyl chloride. Another example. Let's have a bromine this time. This would be butanoyl bromide. All right, so we would have that. And in this case, let's go ahead and pause the video, or we'll stop it. We'll have a second video for the rest of them. We'll have amides and then the nitriles in a separate video, just to let your brains rest for just a second. So we'll see that in the next video.